Hello everyone, welcome back to the course Financial Mathematics for Actuaries. In this week, we are going to learn a topic related to bond risk management, in which we are going to learn the Macaulay duration, the modified duration, and convexity. Specifically, we are going to learn what is the Macaulay duration, how it works, and how to define this Macaulay duration, and we will understand the Macaulay duration with one example, and then we are going to learn what is modified duration, and then eventually we are going to learn what is convexity. So what is the Macaulay duration? Remember that when investing in bond, one of the major concern of investor is the bond maturity and the risk associated with the duration. Okay, so the investors want to know how much is the interest rate risk involved in his investment, and okay, how long it take to recover the investment. Okay, so knowing these informations about the bond can help the investors to choose a bond as per his risk appetite. That means it based on how much the investors want to take the risk. Okay, he will decide what type of bond he will consider. Okay, and the Macaulay duration therefore help us in this regard. Okay, the Macaulay duration basically tells us how long it takes to recover our bond investment based on when we receive its cash flows. It basically tells us the average time until our bond pays us back, accounting for both interest payments and principal. Okay. So the Macaulay duration is named as Frederick Macaulay duration, who introduced it for the first time in the year 1938. History of that time, he has written a book and published in that book. He has commented that only a short-term loan can be imagined to be absolutely secure. Okay, so he created a measure of length of a loan by which the security of the loan of various term to maturity and yield rate could be compared. Okay, note that here the term length is not equivalent or not what we mean are the term to maturity of the bond n. Okay, so this length is actually different from what we have understood so far, that is time to maturity or term to maturity. Okay, so what is the key concept in the Macaulay duration? In Macaulay duration is use the present value weighting of the cash flows, and it assigns the greater importance to the earlier payments. Okay, we can first understand how to interpret the Macaulay duration and what is the importance of Macaulay duration, and we will also understand okay how to compute the Macaulay duration, right? So how to interpret it? First, for our curiosity, we must understand. Okay, so if you will get a higher value of the Macaulay duration, that implies that there is a greater sensitivity to interest rate fluctuation, resulting in the higher price volatility. Okay, if the Macaulay duration is found to be low, okay, that means the lower duration therefore implies that the lower interest rate risk and faster recovery of investment or invested capital. So the Macaulay durations actually will tells us what is the number of period or what is the time or how much time it will take to actually recover your investment back, right? What is the interest rate risk involved in the investment, right? So what is the usage of this, how we will use it, okay, and therefore what is the importance of Macaulay duration? Macaulay duration actually help us in comparing different types of bonds, right? It assists in assessing interest rate risk, how much interest rate risk a bond investment involve, okay? And it is therefore very useful for choosing between the short term bond or the long term bond for our investment purpose, right? And therefore, by knowing how sensitive of a bond price is to interest rate movement, investors can make smarter choice around the maturity, yield, and therefore the portfolio balance. Okay, and also it serves a foundation tool for the modified duration, which is very popular among the investors. Okay, what we are going to learn very shortly, right? Okay, so let us understand the Macaulay duration, okay, or Macaulay duration. So note that Macaulay did not mean the length at the term of the loan, as I have already told you that the length is not just equivalent with the term of the loan. What Macaulay actually mean, therefore? Let us understand this by one example. Okay, take this example. It says, let's compare the following two loans of similar characteristic, which is having the face value of 100 and n is 10 years and the effective interest rate is 10%. So we have this two option here, option 1, okay, and option 2, that is loan 1, okay, which says that you will take a single payment of 259.37 in 10 years, okay, that is 100 is equal to 259.37 multiplied by, okay, the v to the power n with the rate of interest of 0.10, that is 10%, right? And I believe you have already understood how to compute this v to the power n or v to the power 10, okay, right? So again, or in other way, we can simply rewrite it as 100 is equal to 259.37 multiplied by 1.1, okay, that is the interest rate here, the 10%. So we will have 1.1 to the power minus 10, okay, this is what I was talking about, right? So this should be equivalent with this face value, okay. So you will take this option, or you will also have a second option that says the payment of 100 in the first year or 1 year and payment of 23.6 in 10 years, okay. In a way, we have computed as 100 is equal to 100 multiplied by 1.1 to the power minus 1 plus 23.60 multiplied by 1.1 to the power minus 10. So which one you will choose, okay? So which one you will choose? Basically, you maybe, okay, you will choose the second one, right? Why? Because what Macaulay meant was loan 1 is longer than loan 2, in the sense that the bulk of the payment comes later for loan 1 than for loan 2. So if we compare these two, then the length of this first option actually is higher than the length of this loan 2, okay, or the bulk of investment amount, okay, you are expecting to get is actually comes much later for the loan 1 than for the loan 2, and therefore you may be interested in loan 2, okay. So this simple example can therefore, okay, explain us what is Macaulay duration, but let us now also understand deeply, okay. So the Macaulay duration is basically the weighted average term to maturity of the cash flow of the bond, okay. So how do you define this one? let us define the Macaulay duration. The Macaulay duration originally introduced with a flat term structure of interest rate, and therefore we will first understand, okay, the definition for Macaulay duration considering the flat term structure, then we will extend it to the general term structure. Okay. So, in the flat term structure, suppose that the term structure is flat at the annual effective interest rate I. Suppose that a fixed income set of cash flow consists of payments such as K1, K2 up to Kn at time t is equal to 1, 2 up to n, then we will have the Macaulay duration, or we will denote it as Dmac I, or simply D is equal to sum of T multiplied by Kt multiplied by 1 plus I to the power minus T whole divided by sum of Kt into 1 plus I to the power minus T. Okay. So, this is the formula, okay, or that define the Macaulay duration. Okay. It basically tells us what is the weighted average term to maturity of the cash flow of our bond, right. So, let us also define it considering the general term structure. Okay. So, in the case of general term structure, you will simply rewrite this as the same. Okay. So, here suppose that the term structure is RT is positive, okay, RT is greater than 0, where RT is the annual effective yield rate as of time 0 for a 0 coupon bond maturing at time t. Okay, then we will rewrite the same formula as Dmac I, that is the Macaulay duration I, is equal to summation of Tkt 1 plus Rt to the power minus T whole divided by summation of Kt 1 plus Rt to the power minus T. Okay. So, here what we have noticed here, remember that this, like this one, that is the Kt time 1 plus Rt to the power minus T whole divided by summation of Kt 1 plus Rt, okay, to the power minus T is, okay, let us consider this up to this term, okay, like up to this term here as I have written over here. So, no need to in fact highlight it here. So, we have here, this is the weight we have assigned. Okay. So, and notice that this weight is positive or equal to 0, and the sum of the weight should be equal to 1, okay, or sum of the Wt should be equal to 1. Then we can rewrite this formula as D is equal to, or D is equal to Dmac I is equal to summation of T, that is this T multiplied by this Wt, where Wt is equal to this one. Okay. So, we have just understood that, okay, how to define the Macaulay duration in the case of the flat term structure and in the case of the general term structure. Okay. So, basically it tells us the weighted average of the time, okay, t. Let us now understand the same thing but little simple way. Okay. So, in this case, therefore, consider an investment that generates cash flow of amount Ct at time t is equal to 1, 2 up to n, and let us also denote that I is the rate of interest, okay, per payment period, and P is the initial investment. So, for simplicity purpose, we are actually ignoring the subscript here. So, P is, let us imagine that it is an initial investment or the price. Okay. Then the present value of Ct due to, or present value of Ct due at time t is simply PV Ct, okay, and therefore PVCT is computed as Ct upon 1 plus I to the power t, or simply we will compute at Ct multiplied by 1 plus I to the power minus t. Okay. So, we know that here that the value of the investment is equal to the sum of the present value of the cash flow it's generate. Okay. And therefore, we have P is equal to sum of present value of the cash flow. So, P therefore is simply summation of all the present value of the cash flow you are expecting, right. So, now we can define the Macaulay duration as the Dmac is equal to summation of T PVCT divided by P, which is then can be written as sum of T multiplied by Wt. This is the same, like formula what we have written it in the case of general term structure. Okay. So, this way will actually be very clear, right, where this Wt is basically the weight. So, weight, there are k payment per year, then we replace this time t by t divided by k.